I feel like the atmosphere is really electric. I mean, listen to it right now, and this is the last day of the show.
Well, it's a great chance for us to gather new business and see what's new in the industry.
See you at the next IT Expo.
We'll be here.
So before I begin, I just want to get a show of hands of how many of you work in a role that has something to do with security or incident response or malware. Anybody? Of course, that table. Okay, so maybe about 20% of you. So who am I and why am I here talking to you today about cybersecurity? My name, Bilogorskiy, actually means white mountain in Russian. And I was born in Ukraine. I'm half Russian, half Ukrainian. I immigrated to the States when I was 16, and I worked in cybersecurity-related positions at companies like Fortinet, SonicWall. I ran malware security at Facebook for a couple of years, and I was one of the founding members of a security startup called Cybersecurity, which was recently acquired by Juniper Networks, so now I represent them, and I run cybersecurity strategy for Juniper. We have 30 minutes today, so we're going to jump on quite a few topics without going very deep, because it's a keynote. We're going to cover the ABCs: artificial intelligence, blockchain, and cybercrime, and how to combat it. We're going to talk about how behavioral analytics can be used to automate incident response, how to simplify incident response, how to do more with fewer people, and how to build that kind of solution. We're going to talk a little bit about recent breaches as well, and what's happening in the industry. So let's begin. I have been in the industry for about 17 years, and I've really never seen it quite as bad as it is today in terms of the number of breaches, the number of credentials that are circulating on the dark web, in terms of how easy it is to breach every single one of you and your companies. The gap between the attacks coming at us and the ones we're actually able to stop and prevent is significant, and it's growing. And the fact that security is something that you have to keep doing, it doesn't stop ever, right? The bad guys have to be right once, you have to be right all the time. It's always on, 24/7, and it's almost impossible to prevent an incident. That has really been getting worse, so I have some stats to share with you from the Ponemon survey. How many malware alerts and virus alerts that an average company is getting per week? 12,000. Well, how many of these do you think they actually have time to look at and confirm and do something about? It's about 500. So most of the alerts they're getting, they're not even have the bandwidth to process. How many hours are they wasting chasing false positives? And a false positive in cybersecurity speak is when the machine tells you something happened, it didn't really happen. It's a false alert, something that just wasted your time. It's good news because you're not really breached, but it's bad news because if most of your alerts are false positives, you stop trusting them, and then you miss the real one. In converse, false negative is a breach event that actually happened, and you were not alerted by it. So false negative versus false positives. 352 hours every week companies waste chasing alerts that were not real, false positives. And the annual cost of that in terms of money is over $1 million per average company, according to Ponemon. So, of course, that doesn't prevent the breaches. They still happen, and on average, the company is losing about $7 million per breach, and that number is roughly constant every year. So why are breaches occurring, and what are we doing wrong? Well, in terms of protection from cybercrime, one of the experts is Gartner, and Gartner publishes this, the quadrants of cybersecurity solutions. As you know, there's not dozens, not hundreds, but thousands of cybersecurity vendors offering various kinds of protection services and products. And most of them fit into one of these 4 quadrants: prediction, prevention, respawn technologies, and detection. And the traditional approach is to try to prevent breaches, prevent malware coming into your enterprise through tools like firewalls and antivirus, the fundamentals. Problem is the traditional approach has failed because it relies on making a decision in a very short amount of time. You don't want to wait until your attachment gets to your inbox. You can't be slowed down in your browsing for your company. So prevention layer has to function in milliseconds, and therefore it cannot go very deep. It's missing a lot of malware. It's failing to stop it, and that's causing breaches that are happening. Prevention cannot stop advanced malware because advanced malware can now use polymorphism, present different versions of itself each time it infects you. For example, how many of you guys watch Olympics? All right. Have you heard about the Olympic Destroyer? Olympic Destroyer was the malware that was used to attack the opening night ceremonies and was successful because it brought down the press center, the Wi-Fi at the stadium. It was a wiper, allegedly by the Fancy Bear cyber gang, which is tied to the Russian intelligence. And it attacked systems in South Korea related to Olympics. And it was using polymorphism, the same technique I just talked about, where each machine it infects, it gathers credentials, logins, and passwords on that machine. And then it rebuilds another copy of itself, embedding that passwords that it found, and sends it to other machines using Eternal Blue exploit. So initial version of it was hard-coded with the chain domain and some credentials in it, and launched, and it was successful. So we see a lot of high-profile attacks like that, and prevention layer technologies like firewall and AV is just inadequate. Advanced malware constantly changes its look. It can kill processes on the endpoint. It has very complex multi-channel CNC process, and by CNC, I mean the process of the virus talking to its backend server, the command and control, how it gets commands on what it needs to do. It used to be that we've seen very simple, web-based, HTTP-based command and control. Now we can see encrypted callbacks. We can see callbacks piggybacking on regular communication channels like Twitter and Facebook and Dropbox and Amazon. It tries to blend into what you're doing already, but it's actually malicious software on your machine communicating back to the attackers. So the prevention layer technologies are not effective, and even Gartner said that security leaders, the CISOs and the CIOs, really must move from trying to prevent the breach to investing in technologies that help you detect it and respond to it. It's really all about incident response. And the problem with incident response is you need people to do it, and there's just not enough people that know how to do it well. The talent gap in cybersecurity is significant. There's already this year over 1 million unfilled positions, and that's about to grow to 3 million the next couple of years. The pay and salaries for cybersecurity people went up about 7% this year. So everybody's trying to hire cybersecurity engineers. There's just not enough of them to fill these positions. So we have to rely on software and some automation to take that load. And that's where behavioral analytics can come and help us. So I'll explain what that is and how to architect a solution that uses behavioral analytics and how it uses AI and machine learning and what those things are with an example. So behavioral analytics is techniques that use big data databases and scripts and some machine learning models and classifiers to correlate data from different logs and events and third-party servers, learn new threat behaviors, and warn you when something is unusual, an anomaly in user behavior, or an anomaly in the way software executes. So for example, taking a file, running it inside a virtual machine, recording its behavior, and mapping if that behavior fits a clean program or a malicious program is an example of behavioral analytics. And I believe that we live in an age of a new security paradigm, where in security about 10 years ago, most people focused on enforcement and prevention, and then policy, and then the small piece of it was intelligence, sharing information about what they're seeing, exchanging data one company to another. But today, prevention and enforcement is actually the smallest piece of it. Policy is still in the middle, but the most important thing for most companies is intelligence. It's knowing what's happening, threat intelligence, the hashes, the IP addresses, the domains of attacks that are happening, the SNORD signatures and YARA signatures and different ways to detect malware. So sharing that within the trusted community and building machine learning-based algorithms to use that data and reduce your threat risk has really become key. So the way I see the solution is fitting the threat intelligence, which is very important, with the behavior analytics and the machine learning-based approach, and have that power the most important functions for the enterprise, which is detection of new threats and responding to a breach. Because usually what happens is you're an incident responder for a company, and you get these alerts coming in. You're supposed to look at each one and try to understand, one, is that a false positive? Is that a mistake, or is that really that user went on the internet and downloaded malware? So you have to confirm these, and it's not that easy because sometimes they don't really have all of the necessary context. Once they do confirm that it's bad, they need to understand how bad is it and what I need to do in terms of mitigation and remediation. Do I need to wipe that machine and reinstall OS on it? Do I need to cut them off from the internet right away? Do I need to bring that person for cybersecurity training? So figuring out the right action and the right response really takes a lot of time, and they don't have time because they have so many of these alerts. So some of the use cases for behavior analytics that can be deployed today are people like forensics hunters that can work from, here's an infected machine, figure out what happened, what was the root cause. So they go backwards from one virus on one machine to figuring out who attacked you and why. And the threat intel hunters at the enterprise that actually work from spotting patterns and anomalies and try to, from that, drill down to find infected machines, infected computers, and remediate them. So for cyber attacks, the main things for you to know is that what hasn't changed is the way they get into your companies. It's still the internet, and the channels on the internet that are most usually utilized is the web. People browse into websites. It's the email, both attachments in your email and links in the email. And the lateral spread. And by lateral spread, or sometimes called east-west propagation, we talk about one machine infecting another computer in the same network without going out to the internet. So spreading machine to machine within the enterprise, whether it's using file shares, network shares, SMB, PSExec, other methods, that's called lateral spread. So those three are the main ways you will see malware. There's others, but the bulk of it is coming from those channels. And when we design behavioral analytics, we have to make sure that all of those primary attack vectors are covered. Another way to look at really significant targeted breaches that have hit our government, have hit our electoral process, have hit our army, is they use this Lockheed Martin defense terminology of kill chain. How many of you have heard of cyber kill chain? Good, so about 10 of you. Cyber kill chain is this idea that a targeted attack has stages, kill chain parts. And it starts with doing some reconnaissance and figuring out who you're going to hit, what are their names, what are their emails, collecting info on them. And then you craft a special email for them to open. That could be called spear phishing, for example. Then when they open that email, you exploit them, you get them to click on something, take them to a malicious website, have them download malware and run it. And then you're in, but you're not done yet. You start exploring laterally, infecting other machines, looking for really interesting information within their company to really steal. So all of those things, the stages of the kill chain, the common ones are exploit, malware download, malware installation. The command and control activities where the infected machine is reaching out back to your hacker server to say, okay, I've infected this guy, here's all the information about him, what do I do? And you can issue commands to it like you would to a bot. That's why a lot of these infected machines are called bots and botnets. And the lateral activity of spreading within the enterprise and figuring out what to exfiltrate. And of course, the exfiltration is the final step of the kill chain. So when we design behavioral analytics and we try to automate some of the incident response, we have to make sure it works on all of the parts of this kill chain. And it has to work with all of the other third-party security vendors out there, because we can't do everything ourselves. And people already invested money in buying some security technologies, whether it's Cisco or Alien Vault or Carbon Black, whether it's on the endpoint or on the network or many of the other ways to do security. They already spent some money and bought some software that gives them alerts. So it would be best to integrate those alerts into the system and help the machine learning algorithms to correlate these alerts together. So a typical incident process responding to a breach, when I talk to large enterprises, it usually looks like this. They get an email saying something happened, this vendor detected this bad event, and they need to figure out, did it really happen, or is it a bug, is it a glitch, is it a mistake? because none of this software is perfect. Sometimes it's 99% accurate, sometimes less, but it's dealing with millions of events. So it's wrong quite often. And then when they confirm that it's a real malware, for example, they have to understand whether or not they should care about this event and how does it fit into the overall scheme of things, how to prioritize it. So assigning the right threat risk to your alerts is really key, and that's where behavioral analytics can help. And you should care if the incident risk is high. And some of the ways that you can automate figuring out the threat risk is intersecting data from Active Directory and figuring out the identity of the user and what group, for example, he is in. So attacking an engineer versus attacking a CFO in the enterprise. Figuring out the progression, the part of the kill chain that this was. Was this just a recon email, or was this already the exfiltration event that was stealing your secrets and putting it out there? So how far did they get in their breach? Has this attack been disabled by other controls? For example, is this a malware that your endpoint antivirus, let's say Symantec or McAfee or Sophos, have caught? You want to be able to correlate these logs, and when you get a new alert of new malware, you can want to also see, did any of my controls disable this? And based on that, figure out what is the priority, what is the threat risk, what should I do about it? So with behavioral analytics, we can simplify the response process by correlating all of this different data and putting it on the timeline so that the only thing incident responder need to do is load a page and see all of the data from all of the third-party vendors on the same timeline to see what happened when, and hopefully get a suggested action of what he needs to do about it. So we could prioritize consolidated threat profiles for the incident response teams. And I'm not getting anything from my clicker. Get some help? There we go. Maybe it was a breach. So we want to look at ways that we get visibility. Most of the companies I talk to say, not only we don't have enough people, but we don't know what's happening within our network. We get some alerts, but we don't really have visibility into the network activity, into the file activity. I would love to get the most out of all of the investments I already made. So behavioral analytics really is supposed to take the signals from all of these IPS, cloud security broker, security web gateway, antivirus, all of these already installed technologies, and really marry them together in one interface using scalable data storage, like not just Postgres or MySQL database, but something like MongoDB, something that can really handle web scale correlation, and apply machine learning. So when I talk about machine learning, I'm not talking about some AI that is a really like intelligent computer. I'm just talking about math and using simple algorithms that can do what we do, but at larger scale. So for example, when we were building our machine learning for our product, we started with very simple Bayesian-based filters, but then we graduated to building decision trees and looking at what is the false positive rate that we're getting, and trying with different machine learning approaches like random forests, Markov chains, and convoluted neural networks, which are all basically just math solutions, difficult formulas that try to build a curve around all of the data points of your data. You know, all of these try to cluster your data in ways that a machine can understand and suggest a formula for you to use to map machine learning algorithms for you. So for us, the goal was figure out whether a certain file is malware or not. And with machine learning algorithms, we can get a certain amount of accuracy in doing that. We can get, this is 88% likely to be malware because its behavior matches the behavior of other files that we have trained machine learning on. With machine learning, you have the formula, but you also have some weights that you can tune. And the tuning is called training. And generally, the type of machine learning I prefer and I recommend is supervised machine learning, where you combine the best kind of brains of machines with the brains of human experts and have the humans train what the machines are doing with this feedback loop. So offline training, supervised machine learning, which is the approach that Google used for their self-driving car. To me, that works best when AI and machine learning is applied to cybersecurity use case. So building this is really about ingesting data, storing it in a big data cloud database, and running machine learning-based analysis on it, but also visualizing so it's easy to use. Remember, our goal is productivity. Increase productivity by simplifying and automating what we can. So without getting into too much details, what can we achieve with all this? Well, here's how long it takes for an average incident response analyst to do some of the common tedious tasks about processing alert, figuring out who the user is. Was he the one who logged in on this machine at the time? Because sometimes you just get an IP address. You don't get a username. Collect AV logs, what was blocked at the time. Collect network data. Usually they put it in spreadsheets, and they work on these spreadsheets in Excel like it's 1999. We're talking about saving them from having to do that and giving them the answer on their fingertips so that they can handle a lot more alerts than they're currently able to handle. On average, this process takes 2 hours per alert in the calculator that we put together. So already, according to Ponemon, if you start using automation to investigate exploits, each week a company saves 122 hours on that. And separately, using automation to mitigate malware and clean malware from the machines can save up to 158 hours per week. So the main thing I want you to take away is that we don't have enough cybersecurity people. We are really buried under the avalanche of alerts that most of them are not even true. So we really need to rely on computers and not send a human to do a machine's job, but program the computers while checking them and supervising them to take the bulk of the work, take the really tedious, boring stuff, and automate that through correlation of signals, prioritizing the threat risk correctly, adding identity context to each alert, and putting everything on the timeline for incident responders. This should really save the budget and save the sanity of a lot of CISOs. This is a major problem for them. So that's my presentation. We talked about behavioral analytics. We talked a little bit about machine learning and the Olympic destroyer malware. Thank you.